thanks for the invitation. And today I would want to share the contribution of Macau science satellite to the ocean induction studies. And this is our authors, and also Keke. And I come from the Central South University of China. And first, I will give a very short background, and I will show details how we selected the data set. And we use two methods to extract an ocean induction signal. And I will show the result and make a very simple conclusions. So here, I want to share the real properties of MSS-1 compared to other satellites. It has high precision, and also it has a unique low inclination orbit. And more important, it occurs more local times. And here I jump directly to how we select the data set. So in this study, we compared, we used 2 years of MSS-1 data set and also used 12 years Swarm A. And we use the single point measurements. We did not consider the gradients. We did not consider the north-south gradient and the west-east gradients. And the step one is we want to make sure to ignore the influence of the atmosphere. So we strictly using the index, the SZA, the standardization angle. So we make sure the angle is larger than 100 degrees. It means we only use satellite data set at this site. And step two, we want to make sure the environment of magnetic field is quiet. So we use several indexes, such as HP13. So it has 10 categories. We make sure that we use the data set, the index is satisfied 0 in category, 1 category, and 2 category. So in this two category means so it's a very strictly quiet magnetic sphere, and we also measure the change of rain current rate. We make sure the rate is less than 2.0 lambda Tesla per hour. So the purpose is also want to make sure the background is stable. We also consider the solar wind. So we use larger measurements, the emerging electric field. So the amplitude is less than 0.8 minimum volt per meter. And so it means, and the exchange of the energy between the magnetic sphere environment and the solar wind is to be minimal. And we also using the BZ component of the carried by the solar wind. So we make sure it is positive. So it's directing from the south to the north. And as you can see here, this is the direction of the magnetic field. Because this magnetic field is parallel to each other, so the so-called magnetic reflection didn't happen. And it means the transition of the heat, transition the area between the solar wind and also magnetic field is kept to minimal. We also measure the index of the Y component. So we use the absolute value. We guarantee the absolute value of By is less than 3, and it makes sure the current along the polars are to be kept minimal. So all we do is try to make sure the solar wind effect is minimized, and also make sure the magnetic environment of the magnetic sphere is stable and quiet. Because the ocean induction field amplitude is very weak. And so we jump to step 3 we try to remove the effect from the core and crust and also the external source using the chaos model. And the final model we want to, because we have different kind of data sets, such as vector and also the scalar. And for the polar range, we only using the scalar because we try to minimize the effects of the polar currents. And for the lower and middle latitude ranges, we use the vector data set. Okay, so this is this is residual magnetic field. So we test four data sets. One is the panel A shows the result, the spatial distribution of the 2 years MSS-1 data set. The panel B shows the 2 years of Swarm A, and the panel C shows the 2 years plus 12 years Swarm A. And here, the panels D is a distribution and property density. It means all the data sets and the standard derivation is quite close to zero. So from a statistical point of view, the data quality is quite good. And so we have the data set, but we needed the math model to fit in the data set. So we introduced we tested two methods. But the first one is based on the standard time harmonic expansion series. It means the potential of the magnetic field of the ocean induction field can be expressed like this. And I want to draw your attention to the basic functions, which is highlighted by the red color. It's cosine omega t. Here, omega is the frequency of the tidal signals. And so the limitation of this one is based on pure mass. It's based on the spherical expansion, and it ignores the physics information of the orbit of the moon. So maybe it's difficult to extract race weak signals. And method 2 means we use the information of the orbit. So this expression is based on the gravity expansion of the gravity potential. So I want to draw your attention to the basic functions compared to the previous one. So we changed the cosine omega t to the cosine 2 times the delta L. And the 2 means we deal with the semi-delamer tidal such as M2 and also N2. And delta L is the true lunar azimuth angle. So it's a time-dependent angle. The advantage, as you can mention, as you can consider and as you can think, so we consider the real orbit of the moon respect to the Earth. So maybe it's quite good. So now for the method 2, how we extracted the specific tidal signals. So first, we input the residual data set, and we use our EP model try to obtain the coefficient. And then we using coefficient try to generate the time series, and then we apply the TH model to extract the specific tidal signals. Okay, so before I show the models, I want to show you how the data fitting conditions. So also these figures show the data fitting result for the 4 data sets. And the left corner is for the 12 years Swarm A vector data set. And this one at the red corner, top right is the 12 years Swarm A any using scanner. And here is the 2 years MS-1 data set with scanner values. So in each panels, I also calculate the standard derivation for the TH model and for EP model. As you can see, the EP model decrease the standard derivations. It has better fittings, and also for the case of less number of data set, the EP method have very good performance compared to the TH method. So the value of standard derivation is improved by at least 20%. Oh, okay, I show the result. And so for the left side is the real part of the ratio component of the magnetic field for the M2 tidal signal. So as you can see here, for the 2 years MS-1 tidal signals is quite close to the one with 12 years Swarm A data set. Also, I show the result from Graver as a reference result. So I can make a conclusion. So even with 2 years MS-1 data set, it can extract M2 tidal signal quite well, and to some extent, it has better performance compared to the data from the Swarm A. So similar conclusion can be obtained from immediate part. And this is a linear comparison of the spectrum on the Earth's surface for the TH method. So I as you can see here, so for the same period, 2 years data set, the power spectrum on MSS-1 is stable in the higher order compared to the Swarm A. And if we combine these two data sets, the 2 years MSS-1 and 12 years Swarm A is close to the model offered by Graver. And so here I compared the performance of these two methods. So the testing data set is the 2 years MSS-1 and 12 years Swarm A. And the top column is for the result of the TH method. The second column is the result is the EP method. So as you can see, they agree to each other very well. And so this is a comparison of the spectral power spectrum. So they also show very good agreement to each other. So here is my point. I also select the data set focus which is marked by the rectangle. So in the rectangle, I use two methods to generate the time series, and then I performance the analysis, try to extract the amplitude of different components of the tidal singulus. So as you can see here, both methods can recover M2 amplitude quite well, but for the N2, because it's very weak, its amplitude is very weak, the TH method cannot recover its amplitude, but the EP method can recover its amplitude quite well. So this comparison indicates the potential of the benefits of if we using the orbit information of the movement to extract the tidal singulus. So this is a final comparison. So finally, we applied the EP method to extract the N2 magnetic field. So the data set is 2 years Swarm and 12 years. Is 2 years MSS-1 and 12 years Swarm A. We do not use the gradient information, but the second column is from the Graver. He used this Swarm ABC and the 10 years champ, and also both the sync measurements and the gradient data set. So as you can see here, so this new method use 10 times less data set, but you can produce results quite good to each other, even for the very weak N2 singulus. So this is the conclusion. Maybe okay, this is comparison. Last comparison between these two spectra. So as you can see here, and our result EP method has better result at the higher orders, and the difference is caused by in our study we only using the single measurement, single point. We do not use the north-south gradient or east and west gradients. Okay, this is conclusion. So first, I want to make sure to the MSS-1 is ready for the tidal singulus studies, and also comparative combination with different satellites is better. And I also, the main point is, so even for very weak ocean studies, the combination of mass and physics is better than the method and using the mass. Okay, so in the ongoing work, because we have different platform, I have a satellite, we have the ground sat. We also sometimes we have the measurements from the ocean bottom. So maybe we consider a combination all of this platform together to build a comprehensive ocean induction singulus. So thank you.